Awesome, thank you. So hopefully everyone can see my screen and hopefully everyone can see me, and we'll get started without too much ado. All right, cool. So we're going to cover 4 main topics today. I'm going to briefly introduce myself. I will talk a little bit about our team, some of the stuff we're doing in the village today, and then we'll talk about what we're going to cover, what a red team handcuff is, and kind of the conclusion. All right, so first off, to introduce myself, my name's Caleb McGary. I am a red teamer at Microsoft. I have been with the company now for a few years. I am on one of several red teams at Microsoft. So Microsoft is a fairly large company. We have, I think, 4 main red teams. Each one has a different area of expertise. My team is responsible for what is known as EDG. EDG, as you can see on the screen, stands for Edge, Devices, and Gaming. And the way I would explain it to people is if you think about like Windows, but nothing that is actually on the stuff that runs on your computer per se, right? So this includes things like Windows Update, Windows Code Sign, all the build systems, some of the other inherent security that gets baked in, stuff that's Windows, but you don't necessarily touch it, right? And so there are some components that we touch that you may actually touch, but not a ton of them. With devices, this includes everything that's devices related. So say from manufacturing to deployment to the images that go on the Surface Book. And with gaming, my team is responsible for the entire stack. So that includes all of the studios that we own. That includes Xbox, anything that runs on the console, to assessing, testing the hardware potentially, to say figuring out how to cheat in a particular game, to going out and testing a third-party gaming studio that we have just acquired to check the security of them. We are a relatively small team. There are only 8 of us, and I think today most of us are actually present at the conference. We are hanging out in the Village-Serpent channel, which I'll cover in a second. Please feel free to drop in. You can talk to us directly and ask, hey, what's things like in your space, or how is this done in potential at Microsoft? And where possible, we will try and share that information with you. Obviously, there are going to be some things that we can't disclose, but that's kind of the way life is at any major corporate company. I live in Seattle. I have 2 dogs, one of which is featured on the screen up there, and the other one is upstairs, hopefully being quiet and should not interrupt my talk. And I put my LinkedIn here. You can ping me there if you have a question and you want to reach out, you want to try and connect. Just tell me where you're from. Say, hey, I'm from Bsides Seattle, so that way I actually know who you are. All right, so I mentioned earlier, I think in the last couple of minutes, that we actually have a village or something going on here at Bsides Seattle. And I'm going to take a minute and talk a little bit about it. So in the Village-Serpent channel, there is a pinned post. And if you look at that pinned post, it will direct you to securityscenter.windows.com, and it will give you a login username and a password that you can use to log in. And what we have set up here is an enterprise MDATP instance. So MDATP stands for Microsoft Defender Advanced Threat Protection. I think they rebranded it recently to Microsoft Defender for Endpoint. So they changed the name as part of Ignite a few weeks ago. And in this environment, we have onboarded a small domain. So there's a couple of servers, a couple of clients, and we have done some activities within the environment, right? And there is the advanced hunting interface enabled. So it will enable you, if you log in and poke around, to try and figure out exactly what we have done and how. And, admittedly, there are some things that are extremely obvious. So say, hey, accessing LSAS, right? But there are some things that are a lot less obvious. And so the goal of the, experience, if I'm going to call it that, is to see if you can figure out everything that we did using the hunting interface, right? Admittedly, you could drop some other form of forensic tools on the box, and you could, run some sort of analysis and say, get me all the files that have changed between A and B, and potentially detect us right away. But that's a little bit less interesting. So take your time, log in, try and accomplish the challenge. If you have any questions, like I said, we'll be in the channel, and you can ask us about, hey, how's this feature work? Or was this you? Or did you do A, B, and C? Figure out, see if you can figure out how we laterally move between systems, what sort of credentials and account we're using. Poke around and figure out what you can see, and then hit us up. Unfortunately, we don't have any prizes. Just by nature of the way that we stood this up, it isn't necessarily possible to do it in a super awesome CTF manner, but we do have a bunch of stuff there to poke at. It is somewhat unique, and if you are successful in finding some of the more unique things, we have turned on live response, and so you can potentially recover a file off disk and then analyze it and then go from there, right? So swing by and give it a look. Cool. So today's talk is a little bit unique. It's different than most of the other conference talks that we give or that I have given, and the fact that it's not necessarily a hardcore technical talk. When we were thinking about what we wanted to present at Bsides this year, we decided to talk about some of the challenges that we have in doing our job. And so one of the main points that we have as part of our job are our rules of engagement. And this is a fairly lengthy document with a lot of legalese that is written that every red teamer at Microsoft has to sign when they come on board to do their job. And the ROEs, as I'm going to refer to them, will differ between teams, right? So our talk, you should be aware, is specific to us, and it is specific to how we interact and do our work in the business, right? Other companies, consultants, other major firms, whatever, may have different rules of engagement, may have different limitations, different restrictions, but these are ours, and they force us to adapt and think differently in how we approach our statement of work, right? We have to do certain things differently than potentially a real attacker because we have to change the way in which we operate due to these restrictions that are inherently placed upon us. And this talk today is going to be about what those restrictions are, why they matter, and then how we solve them. And our goal is to be able to work around them in such a way that we can continue to do our work and say a happy path without any impacts and still have the business impact, right? So as a red team, our primary responsibility is to be a sparring partner for our associated blue team, which is known as FIRE, and then also help secure the business, right? We want to find vulnerabilities and bugs before the adversary does and then get them pushed out and get them fixed. All right, so we have our happy path scenario, and this is how we would operate ideally if everything went right and we didn't have any interruptions, challenges, or limitations placed upon us, right? The team would get together. Generally, since we're a small team, this may involve the entire team or just a couple of the seniors on the team. And we'll sit down and we'll say, okay, this is our scope. We have EDG. These are the things that we consider high risks, like, hey, there's a new console coming out this year. We should probably have a look at it. We should probably figure out how they're doing A, B, and C associated with that console if we can accomplish something unique. Let's schedule it in. We'll designate some time, whatever, and we'll decide what our goal is for that target. I mentioned the schedule. So usually when we do a test, and I'll reiterate this, we have a set amount of time. So we are definitely time boxed as part of the way that we do work. And we'll calendar something in and say, okay, this is when we're going to do this task. This is the fun part of the job. We get to do the test, and this is honestly why I do the job. I like connecting the pieces and figuring out all the dots and identifying the problem and then exploiting it and accomplishing the goal. We then release the results. So on our team, the way it works is we have kind of a bug bar, right? So if we decide that something is going to be a bug, it has to be considered a violation of the secure development lifecycle. So there's policy, there's rules and regulations that are out there, and if we file a bug, it has to violate one of those items. So it has to be a technical bug. We tend not to file, say, process bugs. We file technical items that would, I guess, be the equivalent of like a GitHub issue against a project, right? We will open a technical bug like, hey, you have an integer overflow here, and this leads to remote code execution, which leads to environment compromise, which leads to whatever else that you need to fix. So we file our bugs, and then we move on. We are involved in bug remediation to the extent that we will buy off on the customer solution, but generally that's, it's fairly light touch, right? The customer gets to look at the flaw, they get to decide how they want to solve it, and then they get to, deal with it. And ideally, we would then go on to our next target, and it would be a kind of an open and closed process, right? Now, the challenge is that's not really how things work. Anyone that works for a major business knows that things are just different. So let's go back to Monday. I will come to work and I start between, say, 7:30 and 8 a.m. and I fire up Outlook, which is my email client that I use. And there's some email in there. It says, from someone that I may have never heard of somewhere in the company. And they might not even be technically inside of our scope, right? But they just managed to find us because we're in the directory. Hey, listen, we're pushing this product to market. It goes out on Thursday, and I need this thing done, and can you help me with it, right? And a lot of times those are going to be generic security questions that we can punt off to another team, right? So we, in our organization, do partner heavily with other security teams. So we have, within like what I consider the Serpent core, there is a component pen test team. They do code reviews, AppSec. They are like a dedicated pen test team of specific components. There is a threat modeling team, a secure architecture and design team, and they do that kind of service for our customers, right? And so a lot of times we can hand the email person off to that customer. But there might be cases where we're like, okay, this probably merits getting looked at. It's something that was a surprise and it fell through the cracks. And so we have some challenges with this, right? So first, what's the monitoring posture? Remember, our job is to not just test the customer's environment, but also to test the blue team's response within the environment. And if there is something new and foreign, they might not have any monitoring at all. And that represents a significant risk, right? It might be better in that case to punt them off to the blue team and be like, hey, onboard to monitoring, do A, B, and C, and then come back at some future point in time, and we will consider you as a service. Timeline. When the business comes to you with a request like this, they don't give you the desired time. It's usually like, we're going to market on this date, or we have this thing that needs to be done by here, and you have to adjust. And then the environment, right? Microsoft nowadays is a very diverse environment, right? We have everything from, say, Kubernetes with Linux. I did a test on something that was that kind of environment recently, down to, say, just straight regular Windows, .NET, a very Microsoft stack. Where on the other hand, I might have something that is, say, Perl, Kubernetes running in a container on Linux somewhere elsewhere within a data center. And the developers that work for us have the ability to choose their technical stack, right? We don't prohibit what they can and can't use. And so this environment may be very diverse. It may be something that we're unfamiliar with, and it may be something that we have to skill up rapidly on. And this represents some challenges when it is our job to potentially compromise the environment and accomplish a goal within it. And so the problem is that forces us to work rapidly, right? And as anybody knows, that when you're speeding, you have to sacrifice a little bit of control of the car when you're going down the freeway. And so we have to sacrifice somewhat with what we can do when we have a very tight deadline in an environment that we may be unfamiliar with, where the controls may not be perfect. And so that's kind of where the handcuffs come in. Because if they weren't present, things might be a little bit easier. Things might be a little bit less stressful and less strenuous for what we're trying to do. It would be much more feasible for us to accomplish our goal if I didn't have some of these restrictions in place. And the adversaries that we deal with, and I will provide specific examples of these, often don't have these limitations in place. And so our job, obviously, is to potentially emulate an adversary. It's not like the only thing that we're responsible for doing, but we need to do so in such a way where it's realistic enough that we are training the blue team, but we're also providing the customer with what they're likely to experience when they are publicly exposed. So handcuff will be the limitation that prevents us from doing that. All right, so without further ado, we're kind of going to get into the first one. So as a corporate red team, right, and we work for Microsoft, we have to be very careful about what resources we use. And so most of the time, if you are attacking, say, a third party, and the example I've got here is Stuxnet, right, which was the major effort against the Iranians that was largely done by the US and Israel at the time. And a modern malware author has the capability to use external resources that they may not have control over, right? They can use shared VMs, they can use email accounts and machines in other countries where they don't really know what will happen, right? Where they are at risk of exposure, where the fact that they can get compromised is a risk that they're willing to accept. And obviously this does, generate some risk to their effort to attack, a said entity. But because the world is like largely interconnected and everything is online in some way, shape, or form, they have the ability to hide within, I guess the data and the traffic and the noise that's out there, right? And so Stuxnet used some domain names, and I've got them listed here. And they're relatively generic. There isn't anything super unique that you might think about them. There's a couple of .orgs, a couple of .nets, a couple of .coms, and they're just kind of a domain name. And thousands of domain names get registered and used on a regular basis, and nobody thinks anything of it. They're words. They're not relatively unique. I mean, there might be some reputation score that might say, hey, this thing is dangerous, but that's really about it. And if someone were to potentially identify these and say, hey, they're part of a malware campaign, the challenge is with attribution. And so when you try and do this in our lab, right, if you log into Village Serpent and you try and figure out where our C2 box actually is, because we do have obviously an attack system that we use to compromise it that is not present in the lab. Attribution is hard, right? And being able to do attribution concretely takes a lot of time. And so an attacker, a real one, can afford to take that risk, right? Whereas we as a Microsoft Red team definitely can't. And the reason why we can't is because we are dealing with potentially very sensitive data. And anytime I pop a system, right, and I exfiltrate some sort of evidence that I was on that box, right, even if it's like something as simple as a screenshot, I am putting Microsoft resources and Microsoft systems at risk, which means I have to maintain very concrete control over where that data goes, what happens to it, and who sees it, right? If I get on a system and I decide to steal some data and I send it back to me in plain text over the internet and someone else is listening and they also intercept that data, then I have just inadvertently exposed Microsoft data to some third party, and I have to figure out how to deal with that. And so that is a hard problem to deal with, right? Because the real attacker doesn't necessarily care if some third party may sniff the data that they're stealing, right? They still get the data in the end. Yes, it might be a little bit less valuable if it's, say, IP, but they'll have a copy of it, right? And the person that sniffs it might not realize what happened. Whereas I cannot even take the risk that someone might sniff it. And this puts some challenges on us because this means obviously I have to have a data store which is under our control. So we have to host within Azure or within our lab environment that we maintain on premises in Redmond. And because of that, there is definitely going to be a traffic feed to our endpoints. And our endpoints are obviously well known, they have to be monitored, they have to be controlled, and the blue team immediately knows where they are. And so if they see traffic going to and from a Serpent endpoint from a potential box, it is like, hey, we should go look at that. We'll probably find them there. And then the response might be different, which isn't something that we want to have happen, right? We want to test the response process from end to end to actually challenge the blue team. And then it adds, challenges for us too, right? Because if we're doing anything unique or specific, we have to have a way of tracking what we do. And so the way we have chosen to deal with this internally on our end, and I have a diagram in the next slide that will talk a little bit about how we implement this technically, is we decided that we would implement encryption, obviously, end to end for any of our tooling in order to allow us to route our traffic through specific third-party endpoints. And it's not just the traffic that we encrypt, right? We also encrypt the payload. So if for some reason the traffic is broken, right, they still have to figure out how to crack and get the payload. And this does add additional tooling overhead. I'll be honest, it's not easy. There is a simple implementation that I'll talk about using Nginx proxies, but it is something that we had to figure out how to do, because then I can choose to put resources in areas outside of my control, because I can guarantee that any sort of data that passes through them will never be able to be broken or taken by someone else that is an attacker, right? And then obviously the start and stop endpoints of that have to be inside our network or a network that we are authorized to attack. And so let's think about this for a second. You've got, say, the cloud, right? And you have your cloud hosting providers, and they're out there. And pick a dozen. And the reason why we like to use cloud hosting providers is because honestly, everything in the world talks to the cloud hosting providers, and we actually have resources that are hosted in other cloud hosting providers. So some of those third-party game studios I mentioned do not always use Microsoft resources or assets, right? And then we have Microsoft, right? So for this scenario, let's assume that we are attacking a target that is internal to our company, and we have figured out a way to go in. And so our infrastructure is on the right, and so it's the red server, and that's going to be where, say, our C2 runs in some sort of virtual machine or a data store potentially, where we'll actually store and control the artifacts, right? We'll obviously have a log server there. We'll have a few other things that are set up in place, not just to log the actions that we as an operator take, but we will actually log and record all the traffic. I think at several different points as it goes in and out of the network. So that way we can say, if someone says, did this byte get sent? We have the capability to say, yes, it did. And let's say we figure out a way to get on that endpoint, right? So I send somebody a phishing email, I include a binary, they click the link because that's what people do. And from there, we then have a connection from there. Obviously, this is going to go somewhere else in the cloud, right? And so the example I gave earlier using Nginx pass-through proxies is actually very simple and very easy to set up, right? So say we're encrypting data already, and we're doing it using, say, OpenSSL, so it is going to already be encrypted, and I ship it off to an Nginx pass-through proxy. The Nginx pass-through proxy will route it to a different load proxy, and then it can route back down to us. And so if someone is, say they compromise that server, right, and they decide to sniff the traffic that is coming to the Nginx pass-through proxy, it is already encrypted. They won't have a way of doing anything with it. And yes, they might actually be watching on that server for potential weakness, and they might potentially be able to redirect that traffic elsewhere, but they can't decode the contents, and therefore we're not going to put Microsoft data at risk. And then obviously we have multiple hops. So we'll have 2 or more proxies chained up to send this traffic between them. And the reason is our blue team is brilliant. They have long since figured that if they see traffic going to a specific endpoint, they can say, hey, what else is talking to that specific endpoint? Oh, hey, it's Serpent resources. This is obviously going to be the red team. And then once again, that may change the response. And that's not something that we want to do. And so we have multiple hops that forces them to say, okay, well, we see traffic going to this cloud provider. It looks anomalous. Or there was an alert on this box that caused us to look and see that where the traffic was going. But we don't necessarily see anything else that's talking to that same endpoint. And so then they have to escalate and start the response process in a much more normal manner, which is good. All right. This next one is kind of significant because it impacts a lot of the way things are working, specifically now that we're in a pandemic and everybody is remote. Obviously, personal devices are out of scope for us, right? And this is, for very good business reasons. But common malware that is out there does not have this restriction, right? So one of the more common things that we're seeing specifically this year is hands-on keyboard operated ransomware. So like ransomware will get on a system, it will report back its an environment, and it actually might get someone that is actively controlling it or potentially directing the spread of it or doing some sort of action as a result of that ransomware infection. So you'll have hands-on keyboard, and that interaction can enable it potentially to cross identity domains, to cross environments, and to spread further. And because this year, more so than any other year when everybody is virtual, you have a lot of personal devices that may be used to connect to corporate environments, right? People will connect to a virtual machine that then has access to the corporate network, and they'll inadvertently bridge, between their personal device and the corporate network. Or they'll have a phone that has like a two-factor authentication token on it, and they'll use it to connect inside to the corporate network. But we can't go after them, right? It's a personal device. There are a lot of restrictions with regards to them, and in many cases it is against the law, to be frank, right? In our case, we also intentionally choose not to ask for that kind of permission because it is plausible that we could go back to our legal team and we could say, hey, can we figure out a way to do this? But we want to work in such a way that the employees or the organizations that we test have full trust in the red team, right? They need to know that if we're going to come in and we're going to own them, we will do our best not to impact any one of them on a personal level, right? As a red teamer, oftentimes you will get on someone's device, right? And it may be a work device, but regardless, you will occasionally see personal data there, right? Someone might be paying bills from their work laptop or something, and they might have, oh, they're buying a house, and because of that, they need to talk to benefits, and they've got like a credit check application on their desktop. And you need to not touch it, right? And you need to be sure that they will have a trust in you that even though they're doing that activity from a corporate device, which may or may not be sanctioned, that their data is secure and that you're not going to go invade their personal life, right? We don't want to go after them. And so the way in which we deal with this is kind of via an assume breach scenario. And this isn't always how we function with these things, right? So assume breach is the concept that you start from somewhere within the environment using some sort of permission level, and you just assume that your perimeter is compromised. Now, in our case, we actually do crack the perimeter. So we don't do it in every engagement, but periodically, so I'd say at least 3 times a year, maybe like once a quarter or so, we will go out and crack the perimeter, right? So it is our job to prove that that risk exists. And then we can use that justification or other access that we get as a result of cracking the perimeter to work to maintain an assume breach posture. And generally for us right now, this is in the form of an unauthenticated network access to the large corporate environment, right? So we don't start inside a specific identity domain. We don't start with a privileged position anywhere, and we don't use trusted insiders, right? And then once again, is specific to our red team. I don't go out and ask somebody to run malware in an environment for us. We will start unauthenticated, just assume we have network access. And prior to COVID, that was a lot, that was very logical because large corporate network, 115,000 of your closest friends are on the network. It is entirely reasonable to assume that somebody will click the link, even if you have breached the perimeter within the last few months, that somebody will respond to a phishing email and run malware, right? And when you have the amount of noise and traffic on a network of that size, it becomes very hard for a blue team to stop and defend and prevent every single instance of it from infiltrating the network, right? So that made sense. If we needed to impersonate someone, we can contact HR and we could work on it. Now, it's a little bit different when everybody is remote because the corporate network is largely just VPNs between devices now. But that same sort of principle still applies, right? But that's the posture that we will usually start with. So inside the network, impersonating someone, but not necessarily a specific user in any way, shape, or form. All right. So the next major challenge that we have is that we have kind of a static tool set. So we're a relatively small team. So as I mentioned at the beginning, there are only 8 of us, and one of them is a manager, and that leaves 7 of us more or less to get our operations done. And we are generally specialized in a variety of things. So our team has what is known as a skills matrix, and every person is required to fill it out once a year. And so it's basically a list of the technologies that we need to know in order to do our job. And you rate yourself on a scale of 1 to 5. That information is public, so it's shared with everybody else on the team, and it is shared with the team lead. And so we can then decide how to get training, where our weaknesses are, what we need to do, who is going to be a specialist and whatever. But even then, with that sort of layout, we still have a very limited resource capability, right? Adversaries are not this case. So in a prior life, prior to working at Microsoft, I had the opportunity to work out east at what was known as the Cyber Defense Center in Annapolis Junction, Maryland, which is right next to Fort Meade. And there were a lot of teams that were there invested just writing particular tooling for the government, say malware, components used for security assessments, stuff to do defensive work potentially. And there were entire complexes of thousands and thousands of employees that worked at that place to accomplish a specific goal. And because of this, if you're attempting to emulate, say, a nation-state adversary, a nation-state adversary may have the capabilities to retool or at least modify a tool of someone else's, right? So they may not always use their own tooling for every single engagement, right? They can basically start fresh from the ground up. They'll have those resources. They can say, okay, we know that these indicators happened, we're burned here. Let's just start afresh, right? It may not always be that way, but they have that capability. In our case, if we spend, say, 3 months developing, say, a really cool malware framework A, and we use it to do something, we are impacted by that. And so for us, the cost to retool is relatively high, right? We may have to start afresh with their design. We have to figure out how to get things done. And if the signature is tight, good, right? So say that the blue team has figured out how to signature a specific tactic that we're using. So say I'm doing some form of memory injection to dump tokens for, something out of memory. And they realize that I'm calling a particular API for that, and that nothing else in the system should ever call this API. And so they put a detection in place, and it becomes a high fidelity detection. The time just to work around that, right? And I might only have to change one API within our tooling, can still take a couple of days, depending on what I need to do, right? So we do have a test environment where we can test things out, and we maintain our own Azure tenant, right? So we own serpent.dev, and we do, security testing there of things before we use them against our targets for this reason, but it still makes it relatively tough, right? And obviously I have a set time in which I need to get something done. And so the way we deal about this is on our team, we have a very tight cadence for how we manage tool development. And I know a lot of red teams tend not to like really structured things. They prefer much more freeform, and I very much understand why. But because we have limited resources and we need to accomplish a lot, we have like a stand up and we operate in sprints. And if you're going to build a tool, someone is going to look at it, and they're going to want to know, what's the purpose and what the impacts of it are and how it will work. And there are a couple other things we also try to do. So I've mentioned one of them on this slide here, that in the industry, there is the concept of what is known as a silent alert. So a silent alert is when there's something that triggers a detection that doesn't necessarily notify the user, right? And so a lot of our tooling is signatured in that way, shape, or form, right? This allows Microsoft or the business to have some form of control over what we do, right? They're able to say, hey, your tooling is only on these systems. It hasn't leaked outside the company. There isn't anything that we need to be worried about. There isn't any sort of response that we need to take. And this is important, right? It's not like we tend not to use a ton of O days as part of our work, but we may use, say, an end day, or we may use a security weakness that is not publicly known as part of the work that we do. And so because of that, we have to guarantee to the company that information will be secure, right? And so our stuff does get signatured to an extent. And then with the TTPs, so which is tools, tactics, and procedures that we use. And I don't have a screenshot of this here, but we maintain a really robust wiki. It's organized by the MITRE ATT&CK framework. And when we have, say, a TTP, there is a time, so it gets created at date foo, and periodically it will get aged out. And by aged out, I mean that we will hand that exact same TTP in a script that will perform that in some way, shape, or form off to the blue team, and we will let them fully signature. Or at least make some effort at stopping it, right? If their signature is bad, we'll continue to use it and we'll let them know that it's bad. But this forces us to innovate on our own schedule, right? So we can say, all right, we're doing this. I know within 6 months, we should not be able to do this. and therefore we will take actions A, B, and C in order to solve this problem potentially, right? If there is a password sprayable endpoint, there's a periodic time where we'll say password spray it, and then we'll be like, okay, we need to get this reported, it needs to be done. You can't necessarily sit on this. And then for the team, and I talked about the skills matrix earlier, we're going to hire people that can do development across a wide variety of languages, right? And we have a couple of people that are experts in .NET, we have a couple of people that are great at Python, PowerShell, scripting, etc., and a couple of people that do native code, C, C++, etc., and that are pretty good at say memory stuff. And this allows us to somewhat spread the workload of the tools development that we need to do across the team, because for the different environments that we target. And I think our team among red teams is somewhat unique that we have such a broad and diverse environment, because we have, say, the gaming studios, and they use a lot of different technologies under the sun. That this allows us to make sure that we are able to cover them adequately. And then obviously we'll do some sorts of, occasionally we'll do periodic tests to just make sure that things are still working. Like I'll drop icar to disk. So icar is a file that will flag a defender alert that will trigger a response automatically. And so we can use this to make sure that, okay, this is happening, but our tool isn't being signatured. And once again, we do this within our own test environment that we have specifically stood up for this purpose. And we do run MDHP in that. That is the primary thing that we use to check and see what triggers the detection, right? It is not the only anti-malware engine that we will face or that we may potentially have to evade, but it is the primary one that we test against, right? So Defender and MDHP. And we do deploy those same tools that we use or work against on our attack systems to make sure that they are secure. This is kind of an interesting one, as this is explicitly forbidden in our ROEs, and it is that basically we cannot weaken the security of any system that we get on. And the way I believe it is worded is that we have to maintain the same posture for the security of the systems that we compromise as the same or greater security posture of a system that we compromise, right? And this is somewhat unique, right? Because it means that there are certain things that adversaries commonly do when they get on a box that we cannot do, right? So if you get on a box and you're an actual attacker, one of the first things you're probably going to want to do is turn off telemetry, right? You don't want to allow login traffic to show what you do afterwards after you got on the system, or at least you want to have some sort of way in guaranteeing that any action you take on the system won't be logged. So you might trigger an exception. You might say, hey, don't note this data. You might turn off some sort of defensive software. Maybe you'll route audit D events to null or something like that. So in that way, shape, or form, your actions aren't taken or stored. We can't do that, right? It's just not something that we have the capability to do, and it's explicitly forbidden. And so for us, the reason why this matters is it makes it harder to actually emulate an actual attacker, right? Normal attackers would relatively easily blind the blue team, and a lot of attacks against, say, anti-malware systems that are out there will involve some sort of denial of service, some sort of disabling of the system, some sort of action which prevents the system from communicating back to the endpoint. We can't really do that, right? We're forbidden from doing such things. We have to make sure that our binaries in the code that we run do not trigger an alert in the first place, right? They might get logged, right? And a lot of the stuff that we do does get logged and potentially generates an event, but it doesn't generate a high enough fidelity event for it to trigger an alert. And this is just because we have to make sure that the blue team has a concrete record or track of whatever we did. If I find a system that's, say, internet exposed, and I've got an example here, right? So there's a system that's internet exposed, and say I successfully brute force it, get through the defenses, and I get onto the box, right? That I might not be the only person on that system, right? There might be someone else that has brute forced that and also gotten on that system. Yes, I might have a better word list than they because I know generally what internal password patterns are potentially for the team or the system that I'm trying to brute force, but someone else may have figured it out. And I have to be confident that I can equivocally say what actions are mine and what actions are not mine in the event that I am not the only person on that box, right? And specifically for systems that are exploitable via an end-day vulnerability, this is a risk, right? There are people that are out there that reverse Microsoft patches on a fairly regular basis, and so that's something that we have to take into account. The other one in the middle is that customer data is a hard no. So for all of you that use our products, well, first, thank you, but understand that we do not touch your data ever. And so if I'm testing, say, Xbox, and I want to go see if I can, say, compromise a specific account, what we will do is we will create an account in advance. So we will create an account just like a regular user. We'll run it through the process, everything, get it onboarded. It'll be an account that we control, that we know about, and then we will go out and we will target or compromise that specific account. but we have to be careful that we don't touch anyone else's account, right? You don't want to trigger a privacy incident. You don't want to trigger customer data exposure in any way, shape, or form. Attackers don't have this problem, right? They don't really care if they look at your data or Bob's data or whatever. They just care that they get to the goal, right? They probably are more annoyed if they see data that isn't relevant than data that is potentially useful for them. So because of this, we've had to take some kind of unique approaches. So I mentioned that we're a tool development team. And one of the things I think that is unique about our red team at Microsoft is we are a build it over a buy it team. And I think that in general, as part of the corporate culture at the company, we are an engineering company. And so people tend to want to build things in-house. And you may have multiple different copies of the same thing that has been built multiple different times. But people will build it in-house, right? Rather than potentially purchase a completely viable product that does that thing successfully off the market. And we do use some COTS products, but very, very few. And so because of that, we have an internal team restriction that our tooling has to go through the same release process that all internal Microsoft products have to do. And that does include things like we get our tooling code reviewed by the component pen test team. We get our tooling threat modeled. Our tooling has to perform authentication at a specific level. And if there's a standard that deprecates a use of specific authentication, so say TLS 1.0 is deprecated, our tooling cannot perform authentication using that deprecated standard either. Honestly, it's kind of annoying at times because it does require us to potentially modernize or change things and then make sure that our tooling is up to the same standard that it needs to be. We log all our actions. We try and do this via automation as much as possible, right? So every operator, or when you are on an engagement, you will have a dedicated attack system. You'll have a dedicated C2 system. Your actions and activities that you take are supposed to be from those systems. And we will collect all the actions and activity that happens on those systems, and we store them for an extended period of time. And then the C2 obviously automatically logs all the commands, anything that goes through it, the traffic, et cetera. And this is deployed within a specific network environment that allows us to capture all the traffic, right? That's mandatory. We don't give it to the blue team when it's done, but we do maintain that data in the event that it's ever needed. Which brings me to the next point, that there is an internal deconfliction process that is set up. So the blue team does have a way in the event that they actually think that, say, something is a real event of making sure that it isn't the red team, right? They have to work for their meal. It's not just, hey, was this the red team, or hey, was this not, right? They obviously have to, provide some sort of reasoning, data, or potential signal for why they believe it is A, B, or C, and we will respond within a timely manner. Likewise, going back to the example from the previous slide, if I brute force an internet exposed endpoint, I will probably let the blue team know right away, right? That's a scenario where I would not be comfortable saying that, hey, this system has not been compromised by someone else, potentially, right? And so if we find a vulnerability of the sort that crosses an identity boundary, right? So say I find a vulnerability that gets me into like a code sign environment, and it's significant, I would reach out. I would say, hey, there's this thing, right? And we have a way of doing that. And I would let them follow their standard incident response process to make sure that the system is not compromised. And that just allows the business to have that kind of level of assurance that we are the only people that are in an environment when we should be, right? That's never a fun scenario to get somewhere and then find out that you're not alone. Red teaming is one of the places where you want to be the only guy in space. You don't want to have other travelers there with you. And I think this is the last major limitation that we have, and that is that we're time boxed, right? So most of our engagements happen from a max of 12 weeks. So we have a max of 1 quarter to do it. And resource-wise, well, we can have as many as 7 people on the engagement, potentially 8. Our manager is technical, and he does lean in from time to time, which is awesome. But we are time boxed, right? And an adversary that comes against Microsoft, or an adversary that attacks a specific property of ours, may have years to do this, right? They may be outside, the legal reach of our company, and they may just literally wake up every morning and say, hey, it's my job to come, go do Microsoft. And whereas we have a very short amount of time to learn about our environment and then compromise the target, right? And some of our shorter tests, we might only have like 2 to 4 weeks, right? It might be a really rushed test where, we have to immediately go out and check something because, say, there was an incident there and someone wants to, see if there's anything else there, right? And then there are obviously going to be times when we can't test, right? So it's October, and the October 2020 Windows update or Windows release is out. Now would probably be a bad time for me to go test Windows Update. Doesn't mean that I couldn't test Windows Update. it just might be a bad time for me to do it. And one of the things that I want to do is maintain a friendly relationship with the business so they don't get mad at me, and they will let me come and do the testing. And so I'm going to delve into a little bit more detail. So this is one of the cooler pieces of tooling that we've written. And I think the next slide I have here will talk a little bit in detail about how the tooling works. And so remember how I mentioned our assume breach mentality. So one of the things that we prefer to do is not have to ask for a user, right? Or not have to say start with an unauthenticated network user somewhere, right? That makes the test a little bit less realistic, right? So instead, what we'll try and do is during the course of other tests, right? Occasionally you'll get into an environment and you'll be like, this environment isn't super useful. We're not necessarily testing it. This didn't land where we thought it 100% would land, right? You do plan things out, right? You're not going to try and wander, across the entire corporate environment or the entire scope of whatever you're testing. But sometimes you'll get some access and it just doesn't make a ton of use. We will persist there, right? And we invest a significant amount of time into persisting there, right? So that way, if I ever need to come back and test something that is, say, 1 to 2 hops away from where we are persisting, I can activate that persistence. I can then perform the actions that I need to do in a much shorter, quicker manner. And it forces the blue team to have to hunt for that persistence off band, right? This gives them something to look for on a daily basis, right? They might be specialized in hunting in a particular environment. So say someone is specialized in hunting within the gaming telemetry, and we might not be testing gaming on any given day of the week. But if we are persisting with that environment, that person that's working there, looking at the telemetry, probably has a signal somewhere where they can, potentially find us. It might be hard for them to figure out what it is, but we intentionally choose to persist and leave artifacts in specific places, so that way we can challenge our blue team and force them to actually understand and make sure that they have the coverage of the telemetry that they need. Obviously, there's automation involved. And this does require us to plan out our engagement several cycles in advance, which obviously doesn't always work. As I mentioned, sometimes the business comes back and says, hey, we need you to do A. But if we have that persistence, it will work. And so the framework that we've built is fairly simplistic. So when we were thinking about this, it's been a couple of years now before we started building this. The idea being that we wanted to put minimal effort into it, right? But we wanted to have something that would adequately enable us to properly translate or talk to the targets we're persisting on. And so in this diagram here, I've got a controller and a storage. And so the storage account you should think of as something just like an Azure blob, right? You can use any storage of your case, right? So basically it just hosts some data. In our case, it will eventually host an implant that we're going to send back to our target, right? And the controller, once again, fairly simplistic. Not a ton of coding skills required. It just needs to talk to some endpoints and manage things, right? And we use a pattern in such a way that enables us to basically load, it's called an observer pattern for those of you that are developers, to load different endpoints that it needs to talk to and push data to them. But the controller is fairly simple. It just checks a key value pair against a database, and if so, it then grabs something from the storage blob and I'll return it to that endpoint where it needs to go. And then we've got our targets, the internets, and transports. So, and the controller, as I mentioned, can talk to the transports. So, and our C2 is a separate entity outside of this, right? So the C2 is a large investment, right? We are not the primary authors of the C2 that we currently use at Microsoft. It is developed by another team, although we do contribute. There is largely one C2 that everybody kind of contributes to that is used by the red teams at Microsoft. But we are the primary authors of the persistence toolset. And the reason why we do this is, say there is a change in the C2 that would require us to like re-roll the C2 completely, right? Hey, there's a security bug in it, you gotta blow it away, gotta build a new one, right? You don't wanna lose your implants, you don't wanna have to deal with, re-getting your positions within an environment. And so the persistence framework is built to maintain those positions in such a way that we can securely know what's going on. Now, all right, as I mentioned, the storage is basically gonna hold implants. And an example here would be, one of our transports is Azure Active Directory. And almost any system in the world that is, say, Microsoft owned will talk to Azure Active Directory in some way, shape, or form. And you can look up users within your directory, right? So assuming you're running under the context of a specific user, you can look up a user and you can look up their profile and you can look up some strings that are associated with that user, like properties, right? And there is a popular multimedia application that is out there that has a small bootloader, or I guess a small loader application that runs on startup if you log into your operating system. to prepare it to load, so that way it doesn't take forever to boot, or the multimedia application doesn't take forever to start up, right? And this multimedia application, it loads a font driver, and that font driver does not exist, right? But because it checks for it every time Windows boots, it goes out and it looks to see if it's there. If so, it loads it. If it doesn't, it goes and loads some script, right? And we know where that script is located on disk. And so we can change that script, or rather we have modified that script in this case, let's say on one of our impacted boxes that runs this application, to check for a value in Azure Active Directory, right? It's relatively normal. It's most likely going to be expected network traffic. There's no big red flag. Hey, it's just looking something up out of Azure Active Directory via, an encrypted connection, whatever. It doesn't trigger any alerts by default. And what it does is it may go out and look up for a user, and it may check a specific profile property. And then it will say, is the profile property signed? If so, do something. If not, do nothing. And it comes time for us to activate that persistence mechanism, right? So we may have placed it on this person's box, and it triggers maybe once a month. And so when I talk about persistence here, I'm talking about long-term persistence, right? We might hide out in an environment for months, potentially as much as a couple of years before we decide to activate our persistence mechanism, right? Now, we're going to activate this mechanism. And so I'm going to go out, and my controller will reach out to Azure Active Directory. It will modify a property on this profile, right? So it's a user that I created, right? So I have the ability to update it with, say, an encrypted or signed string. Next time that person boots, their application will reach out. It'll retrieve that string of code. It'll say, hey, this is signed properly. Can I decrypt it, right? Because we bake in a key in our persistence mechanism that is left on the client, and then it will execute it, right? And what'll happen is we'll then ship an implant down to that affected device, right? So they'll reach out, we'll retrieve something from storage, and it then gets shipped down to the device. That implant will then call back to our C2, and we are immediately active within the environment, and we're generating live traffic, right, to the C2, because the implant obviously doesn't call back like on a monthly basis, right? It might call back using a jitter, at most once an hour, right? Because operators need to do stuff. They need to have a much more timely callback to work with the device. And the code that runs on the targets, or the clients, is often throwaway code, right? It does like two things, and it has to do these two things, right? It has to make sure that the payloads that it get are signed and that they are encrypted properly, right? So it can decrypt them, and then it can validate the signature, and then it can then execute them. So that way we can be sure that any code that it executes is from us and is, under our control. But we invest time into figuring out how to persist on devices that we get onto. And a lot of times we make our persistence specific to the environment, right? If I get on a web application and I notice it's running some sort of code at startup and I can inject into it, I might choose to persist that way. Whereas if I get on, say, a Linux box and I can add a cron job, I might choose to persist that way, right? But we invest time into making, and we have some components, right, to make sure that these persistent scripts run in a very specific manner. And then the other portion, so from the transports on, all that is generic, right? I only need to write the stuff that updates, say if I'm using GitHub as a transport mechanism, I only need to write the code that pushes stuff to GitHub or makes a change that the persistence mechanism can check once, and I can reuse that. Because that is outside the reach of my blue team, they can't signature that, right? Because I'm using a different mechanism to communicate that they don't have control over. And that forces them to always be hunting, always be responding, and it lets us start from within environments in an assume breach mentality per se, right? Because we've popped in, we've gotten our persistence mechanism there once, and they may have trouble finding it. So let's go back to our scenario at the beginning where we were targeting foo, right? So the customer came and said, hey, can you do foo? Assuming foo is valuable, we'll say yes, right? And we might even have, say, infrastructure already built, right? So we use Terraform heavily so that we can deploy all of our infrastructure, with like 1 or 2 clicks. We might already have a persistence mechanism that is 1 or 2 hops away. We might be able to activate it within, say, the next week, right? Because the challenge with persistent mechanisms is they're not always readily available to be activated. But it might only be 1 or 2 hops away. And so that will let us do a test of the environment that can help us challenge our blue team right? Because they'll suddenly see some signal start up. They'll suddenly see something potentially going against a target. And we can evaluate the security of that target in such a way that they'll be challenged. And to wrap things up, this largely works because we have fairly tight coordination with our blue team, right? We have gone through the trouble of sitting down with the blue team, which, like I said, is called fire in our place. And they are some of the best hunters I have ever worked with and best forensics people, and literally one of the best blue teams I've ever had the privilege of working against. And they know we're going to do it, right? They know that we have this sort of tooling in place. They know that we have this sort of mechanism. They know that it's something that they need to figure out how to deal with. And they are accepting of it, right? And it lets us challenge them and continue to meet the business needs without having to break our rules of engagement, right? Which is pretty awesome. All right, any questions?